Hello, my friend, and welcome to the second volume of this course series. Now that we know about Go variables, loops, conditional statements, and basic functions from Volume 1 or equivalent, it is time to study arrays, slices, maps, structs. And we start with arrays because they are the foundation for everything else. So here's what we are going to do in the next few sessions. First, I will introduce arrays and then review the for loop and also introduce the for range loop construct. Next, I will introduce slices, since those are the ones that we will be using for most of the array exercises. Every slice is built on top of an array, and for that reason, we must start with the arrays, even if we will not use them directly. Robert Pike, one of the designers of the Go language, once wrote on the Go blog that arrays have their place. They are a good representation of a transformation matrix, for example, but their most common purpose in Go is to hold storage for a slice. Well, let's begin with arrays then. I'll see you on the next video, my friend. Thank you so much. Hello and welcome to arrays. In Go, an array is a data structure designed for indexing a series of data units of similar type. The data units can be represented in raw format, or they can be stored somewhere else, such as in a variable previously declared, but that variable must be of the same data type. And so here in this picture, I am saying that every element of this array must be an int. This is just an illustration. We will learn how to declare arrays on the next video. As for indexing each data location, we do it numerically, starting from index 0, index 1, index 2, and so forth. Here on index 0, I can place any integer, such as for example 33. Then on index 1, I'm storing the value 55, and next the value 739, for example, which resides on index 2. Notice that the last index position is 2, but we have 3 items, and that's because arrays always start at position 0. Another thing to keep in mind is that in Go, arrays have a fixed length. This array has a length of 3, and that means that when we declare this array, we must preset the number of items the array should contain. If for some reason you want to have an array that varies in length, then you should use a slice, which is a variation of an array. Now notice how all items are of the int data type. Both arrays and slices only accept similar data. My array example here accepts values of type int. If you intend to create a structure in Go that accepts mixed data types, then you should use a struct, and those will be covered later. So in this video, we have seen a few concepts. Arrays are slots of memory containing user data. All data in an array must be of similar data type. The location of each data slot is called an index. Indexing always starts from 0, and because it starts from 0, the length of an array is always one digit higher than the last index position. Okay, now that we have a better idea of what arrays represent, let's see how we declare arrays in the Go language. And we will do that on the next video, just to keep things simpler. I'll see you there, my friend. Thank you very much. Hello, my friend. For this experiment, I want to create an array of type string that holds 4 values in it. So first, I will start by declaring a regular variable of type string, var colors string. But since I want this variable to hold 4 different colors, I prefix the data type with square brackets and add the number 4 to it as length. And now the question is, what is the data type of this variable? The data type of this variable is for string. A for string data type is a string data type with a length of 4. And by having a length of 4 elements, it makes it an array of 4 elements. The word array here means an orderly set of values, like an array of different colors, or an array of famous guitarists as another example. Here's a question. If you still remember, the default value of a string variable is a blank space, right? What should the default value of a for string variable be? The default value here is 4 separate spaces, 1 space per each index position. Another question. Other than having the default values, how can we reassign an index position to a different string value? Of course, we could assign other values to an array at the time of declaration, and we will see how to do that later. But for now, we will reassign values after the declaration. just as we do with regular variables. So, to answer the question, to reassign the index positions, we use the square brackets as a suffix and pass in the index number. Here's what I mean. Colors on index 0 equals blue. And now the first location in the array, which is index 0, contains blue in it, but the other three indexes still contain blank spaces. Let's test it by printing array colors to screen. And when I run the code, I get blue followed by a bunch of spaces. Let me assign one more color for testing. I'll reassign red to index 3. Colors 3 equals red. And now when I run the code, I get blue space space red. Here's one more experiment. We know that index 3 is the last item of the array because it started from 0 and it has a length of 4 elements. But what will happen if I attempt to assign a value to index 4? I assign index 4 to green, and when I run the code, I get the following error. Invalid array index 4, out of bounds for a 4-element array. So index 4 is out of bounds because the maximum index allowed is index 3. Okay, in this exercise we learned that an array is just like any other variable, but it holds more than a single value in it. We have also noticed that the length of the array is part of the data type designation. This array is not a string type. This is a 4-string data type. And just as in string variables, a 4-string variable or array receives a blank space per slot as its default value, unless we assign values to it when declaring the array, and we will see how to do that on the next exercise. And finally, to reassign any of the array locations, we pass the index number as a suffix inside of square brackets. Alright, let's learn a bit more about arrays on the next session. I'll see you there, my friend. Thank you very much. In the last session, we had learned how to declare an array using default values, like for example, var names3 string. Here, the current value in each array element is a blank space. Similarly, if this array was of an int type, like a 3int type, the default values would have been 0, so we would have 3 zeros. Once the array is declared, we can reassign different values to each index. Here, I am reassigning the string Mary to index 0. Okay, what about assigning values to the array during declaration? We can do that by adding a pair of curly braces after the data type declaration, and then add some values. We don't need to add all 3 values. We could just add one, for example, and the others would become blank spaces. And in addition, we could also use the braces without having to assign any values, and in that case, all values default to blank spaces as well. However, to complete this declaration and assignment, we must also add the assignment operator. So here, after the variable name, I insert the equals sign. In summary, we are assigning a 3-string type array to variable names. Great, now since we are declaring this array inside of a function, we could also use the short declaration version. And we do that by deleting the var keyword and adding the colon equals declaration assignment operator. But please remember that the declaration shortcut is only valid when I pre-assign values at the time of declaration, and it must be inside of a function such as, for example, main. Well, to be clear, the short assignment is valid whenever I use the curly braces, even if I don't assign any values to it. Okay, let me print the array values to screen just for testing. As you see, all elements were displayed as one string representation. In fact, anything displayed on screen is always automatically converted to a string value, but the original data is not affected. Moving forward, after the declaration, we can access each element of the array by addressing its index number. For example, I could print the value of index 0 by adding square brackets and a 0 as a suffix to the array names. Another action we can do is to calculate the length of the array by using the len function. Let me print the length of this array just to see how the len function works. And the result is 3. Good. Knowing how to calculate the length of an array can be useful for many reasons. One of such reasons is to find the index number of the last item in the array. Of course, I can address the last index number directly, which in our case is names2, but Arrays can be very long, and we might not know the last index location. In that case, we could use the length of the array to calculate the last index. For example, to print Tony, which is the last index location, I could use names, then put function len inside of the square brackets, and subtract 1 from the result of calling the len function. So why do we subtract 1 from the length to get the last indexed item? We subtract 1 because the last index is always 1 less than the length of the array. This array is 3 elements long, so the last item should be on index position 2. Let me run and test the code. And the result is Tony. Okay, in this exercise we have learned how to assign values to an array when writing an array declaration. And we do that by ending the declaration with 2 curly braces and write the values in there. When adding values during declaration, we must also use an assignment operator after the variable name. In addition, we could use the short declaration operator instead of using var, but only if the array declaration is written inside of a function, such as, for example, the main function. In this exercise, we have also introduced the len function to calculate the length of the array. The len function will be used extensively in our exercises. Here we are using it to automatically calculate the location of the last item in the array. Okay, very well, my friend. I'll see you on the next exercise. Thank you. Hello and welcome. In this session, we are going to see how we can apply a specific index number to a specific data item. And we can do that by writing the index number followed by a colon and then the data we want to assign to it. In addition, don't forget to add a comma if you are going to add a second item to the array. For example, here we have an array of colors with a length of 5. Index 1 is manually assigned to blue, and that means that index 0 is a blank space. Then red automatically takes the next index, which should be index 2. As for index 3, it is also automatically assigned to a blank space. And finally, the last index is manually assigned to green. Let's run this code to print the results to screen. And here I see a blank space, then blue and red, then a blank space again, and finally green. So now we know that we can assign a specific index number to a specific data item when declaring arrays. We do it by adding the index number, followed by a colon, and the data value. Great! On the next session we will review for loops and put them to use to traverse array data structures. I'll see you there, my friend. Thank you. Hello and welcome. In this exercise I will introduce the for loop. The for loop was actually introduced on volume 1, so today I will review concepts, and on the next video I will expand a bit more about for loops in the Go language. So there are basically 3 forms of using the for loop in Go. In the first form, the loop is controlled by a Boolean outcome. If the value is true, the loop keeps cycling. If the value is false, the loop stops. In this example, we have 2 variables, x and y. And then we have a for loop that increments x for as long as x is less than y. The loop will eventually stop when the value in x reaches the value of y, which is 5. The second form of using a for loop initializes the condition first, such as, for example, I equals 0, and then it looks for a Boolean true as the condition to cycle the loop, or a Boolean false to stop running. But in this style of looping, you must also include a way of incrementing the original condition, otherwise the loop will run forever. So here I have an array of colors, and then I initialize the loop counter as 0, which corresponds to the first index number of the array. And next I state the condition in which the loop should run. And if this statement is true, the loop will cycle. But if the statement is false, the loop stops cycling. So here I use the number 4, which is the length of the array, and then I increment the counter so that the loop traverses each item. And finally, in the body of the loop, I print the value of each index number corresponding to the current value of variable I, the counter. Now, using the length of the array works well because the counter starts from 0, and by the time the counter reaches 4, the loop exits without having to print index 4, which would have thrown an overflow error since the last index in this array should be 3. In addition, and to make this loop portable, as we may not know the length of the array, we can use the len function to automatically calculate the length of the array. This is a very common way to loop over arrays, but on the next video I will introduce the for range loop, which is a more idiomatic way of looping over arrays in the Go language. So as a recap, Go uses the for loop in all its loop constructs. And to customize the for loop, we can add a condition in the loop signature and cycle the loop until that condition is met. Or we can initialize a condition and then increment it until it reaches a certain outcome. When using loops to traverse an array, we can use the length of the array as the condition to display the data from the array. And for that, we can implement the len function. On the next exercise, we will see how to use the range keyword to loop over arrays, which is another way of accomplishing the same thing. Okay, my friend, I'll see you on the next exercise. Thank you so much. Hello and welcome. On the last demonstration, we had seen how we could use the len function in a for loop to calculate how long the loop would run. However, since this is a very common task, Go offers us the range keyword, which automatically calculates the length of the array in the loop construct, as well as it increments the array. The range keyword is not limited to arrays. It can also be used in slices, maps, and string values, and we will see all that later. So here we have a range loop, and we can read the code as follows. For I in the range of array colors, print the color in position I. And of course, variable I stands for index. Notice how the range keyword abstracts both the length of the array and the increment command, so we don't have to worry about those two. Let's test the code to see what it does. And it prints all the elements of array colors. Hello and welcome. I hope you have done the previous exercise, but if not, we are going to do it again anyway. As you know, repetition is the only way to master this stuff. We begin by declaring an array of type int with a length of 5 and assign to it numbers 1, 2, 3, 4, and 5. And then we create a for range loop to traverse array odd nums. Now, the exercise wants us to only display the odd numbers, such as 1, 3, and 5 in this example. And for that, we can use a conditional statement that says that if the value does not have a remainder of 0, then the value must be an odd number, and therefore the number should be displayed on screen. The modulus operator was covered on volume 1, and we are just using it here for practicing reasons. On the other hand, if the value in the array does not qualify as an odd number, then it must be an even number. Therefore, according to the exercise, we should display 2 dashes instead of the number. So here we can simply use an else clause and print the 2 dashes whenever the if condition fails. All right, let's test my code. And it prints 1-3-5. All right, great. I hope you had fun. I'll see you on the next topic, my friend. Thank you. Hello and welcome. In this short video, I'll show you that when we pass data from an array to another variable, the data is transferred by value, just as it happens when we assign a regular variable to another variable. The term by value means making a copy or duplicating the data. So when I assign an array variable to another variable, I'm making a copy of the original array. In other words, the new array has no connection with the original array. They are independent of each other. And here's a test example that proves that arrays are passed by value. If you want to test it yourself, the script is available for downloading in case you don't have time to type it by hand. So here, x is a 4-string array. Then later I assign x to variable y, and as you can see in the result at the bottom, both x and y contain red, white, blue, and gray. And then further down the page I reassign index 0 of x to the color pink. But as you can see on my next testing result, the index 0 in array y remains unchanged, as it is still red. And that means that array y is independent of array x, so any change in either array will not affect the other. So in summary, when assigning an array to another array, just as when assigning a variable to another variable, the Go compiler makes a copy of the values. On the next video, we will review passing by reference, which is done when we pass the memory address of variable x instead of passing the values directly. It is important to be familiar with both methods of passing data around. I'll see you there, my friend. Thank you very much. Hello and welcome. The code you currently see on screen comes from the last exercise. Please pause the video to type it in your playground or download it from resources. On the last exercise, we had seen that data in arrays is passed by value or by copy. So as you see here, x is assigned to y, and variable y becomes an independent array with similar values as x. And as you can see at the bottom, when I changed index 0 in variable x to pink, array y remained intact by keeping red as its first value. We could have passed the data by reference instead of by value, which we will do in this exercise. The thing to keep in mind when passing data by reference is that both variables x and y will have the same power to change values in array x. In other words, both y and x will change the values in x. How do we pass by reference? We pass by reference by assigning the memory location of variable x to variable y, instead of passing the values themselves, which would have been a copy. Okay, how do we tell the compiler to assign the memory address of x to y? If you remember from earlier studies, to tell the compiler that what you want is the memory address of variable x, we prefix x with the ampersand symbol when we make the assignment. So here, I add the ampersand symbol to x. However, variable y does not become a 4-string array as we have it in array x. And why not? Well, we know that the data type of variable x is a 4-string array. What is the data type of variable y? If you remember from earlier studies in volume 1, a variable that points to another variable is a pointer variable. So instead of being a 4-string variable as x is, variable y is a pointer 4-string variable. And we can visualize the difference when we run the code. Here, we have array x, which is a 4-string variable, and here I have array y marked as a pointer 4-string variable. Also, notice how, contrary to what we had when we passed x to y by value, variable y now reflects the changes made in variable x. The index 0 in y is now pointing to pink as well. So that is another thing to keep in mind. Any changes made in variable y will affect variable x, and vice versa. Let's test some code. Below the x0 reassignment, reassign index 1 in y to the color black. Now, when I run the code, it shows that index 1 in both x and y have been changed to black. Variable y is a reference to variable x. In fact, there is only one black or blue or gray items. They all reside in location x. Variable y is a reference to x, and it does not contain any values of its own. The ampersand symbol in this output result tells me that y is pointing to some memory address where pink, black, blue, and gray reside. So another question is, how would I print the real values instead of the memory address representation using variable y? Again, from earlier studies, we know that we need to dereference a pointer variable if we want to fetch the data inside of that memory. To dereference variable y, we can prefix the output identifier with an asterisk, just as we did to dereference any other pointer variable. So if I prefix the first y output with an asterisk and run the code, I will get the regular array data on screen. And as you see, the second output still tells me that it's pointing to a memory container that holds some array data. My friend, we could go on and explore array pointers deeper to accomplish complex outcomes. However, using arrays in Go is not a very idiomatic practice. Go has a better option to work with arrays than working with them directly. And that is by using a data structure called a slice, which is a higher abstraction for representing arrays in practical Go. Go uses arrays in the background, but it offers us a more versatile way of working with data via a slice. A slice is a subset of an array, and this will become clear as we move forward in our studies. At this time, we know enough about arrays to begin exploring slices of arrays. We have covered quite enough about arrays in Go. They are the foundation for building slices and other data structures. Any further array manipulation studies will be done by using slices. On the next exercise, we will use the same array X we have been working with to see how we can cut it into an array subset or a portion of an array, and that will lead us to understand slices. I'll see you there, my friend. Thank you very much.